So we've already spent some time talking about sequences and series in general. With this lesson, we're going to go back to sequences, but we are going to focus on something called arithmetic sequences. A lot of you guys are going to want to say arithmetic. It's pronounced arithmetic sequence. Essentially what it is that you start with some number, and then you add the same number each time. So in this case, we've added 4 each time. So this is an arithmetic sequence because of the fact that we're adding. The number that you add is called the common difference. So if you look at it in this way, right, we started with 5, added 4, and got 9. We took 9, added 4, and got 13. We had 13, added 4 to get 17. Took 17, added 4, and got 21. So, because of this fact that we're adding the same value each time, that common difference is 4. What this is telling us is that in order to find the common difference, essentially what we have to do is take any value in the sequence minus the previous value, and that's going to tell us the common difference. So they have to be 2 consecutive values in the sequence. So for this next example, right, we're going to just find the common difference for the sequence. So to get from 20 to 13, we have to subtract 7. From 13 to 6, we subtract 7. From 6 to -1, we subtract 7. From -1 to -8, we subtract 7. So D for this sequence is -7. The next example asks us to find the first 5 terms for each sequence. And we get told the first term is -14, and the common difference is 6. So what we'll do is we'll start with -14, and then we add 6. So -14 plus 6 is -8. And then -8 plus 6 is -2. -2 plus 6 is 4. And then 4 plus 6 is 10. So here are the first 5 terms of the sequence. We can continue this on if we need to. The next one, we're actually doing the same thing, but they write this out a little differently. They're saying a sub 1 is 1.5. That means that the first term in the sequence is 1.5. And then it tells us that the difference is -0.5. So what I'm going to do is subtract 0.5 from it, and I find that my next term is 1. And when I subtract 0.5 again, I get 0.5. If I do that again, I get 0. And if I do that again, I get -0.5. So again, the first 5 terms of the arithmetic sequence. This next slide is going to be a little bit difficult to follow, okay? But what we're doing is we're actually generating a formula. So we have a sub 1 is the first term of our sequence. So a sub 1 is equal to just a sub 1. To get the second term, we take the first term plus the difference. To get the third term, we take the second term plus the difference. That should be easy enough to follow. However, the second term, right, we're going to refer back to here, is really a sub 1 plus d, so that's this, plus another d. So when we combine those, we have a sub 1, which is here, and 2 d's. We do that again with the fourth term. We have a sub 3, which they got from here, plus the difference. Well, a sub 3 we figured out was actually this, so we can rewrite that and add another d to it, which came from here. We have a sub 1 plus 3d. If we continue for the fifth term and the sixth term, what we end up finding is that to find any nth term, we start with the first term, and then we add d times n minus 1. So in this case, it was the 6th term, so 6 minus 1 is 5. So we multiply our difference times 5. Again, so here's that formula. When we have our first term as a sub 1 and our common difference of d, to find the nth term, meaning I could find the 100th term if I wanted to, or the 592nd term if I wanted to. All I'd have to know is the first term and the difference and which term I'm looking for, and I can use this formula to find that term of the sequence. So we're going to actually use that information to find different terms of the sequence. So the first gives us a sequence. It gives us 4 values, and we're asked to find the 16th value and then again the nth value. So what we need to do first of all is identify D. And if I look here, this is minus 3, minus 3, minus 3. So D is negative 3. So then all I need is the fact that I'm looking for the 16th term, so a sub 16, is equal to, take my first term as 23, and this is a negative 3, so I'll use minus 15 times 3. Or I could have written plus 15 times negative 3. Either way would be fine. From there, you're just going to plug that into your calculator, and you find that a sub 16 is equal to negative 22. So to find a sub n, we take 23 minus n minus 1 times 3. And from here, all we're going to do is distribute. So we'll do a sub n is equal to 23 minus 3n minus 3. So I have like terms that I can combine. And actually this is a plus 3 because there's this negative here. And so I get a sub n is equal to 26 minus 3n. The next sequence, we're told we've got a sub 4 is 18 and a sub 5 is 22, and we need to find a sub 10 and a sub n. So the first thing that we need to do here is find the difference. Well, a sub 4 and a sub 5 are consecutive terms, so I just have to subtract them, and I find that my difference is positive 4. From here, I need to find a sub 1, and to find a sub 1, what I'll do is I'll take my a sub 4, which is 18, and set that equal to a sub 1, plus, this is a sub 4, so I want 3 times my difference. So that's a sub 1 plus 12, so I get that 6 is equal to a sub 1. Now I have that, I can find a sub 10 pretty easily. 6 is my a sub 1, and I have 9 times 4. Sorry about that, that was the bell. So 6 plus 9 times 4 is 42. So a sub 10 is equal to 42. To find a sub n, I'll take 6 plus my difference of 4 times n minus 1, distribute that, and I get a sub n is equal to 2 plus 4n. Alright, so our last problem gives us 2 different values. We have a sub 6 is 9 and a sub 15 is negative 36, and it's our job to find a sub 1. So I like to start this with the formula that I'm familiar with, that a sub 15 is equal to a sub 1 plus 14 times d. One thing that can help you with this is to remember that this number plus this number, right, these two numbers, have to equal this. So 1 plus 14 is 15. Now, I don't have a sub 1 and I don't have d. So the first thing that I need to do actually is find d. And what I'll do is I will use the numbers that I do have. So I have a sub 15, and that's equal to a sub 6 plus, now remember what I said, the number that goes in front of d right here, plus 6 has to equal 15, so that number is 9. So it's plus 9d. Well, a sub 15 is negative 36, a sub 6 is 9. When I subtract 9 from both sides, and then divide, I get that D is equal to -5. Now I can use that information and either one of these values to find the value of a sub 1. It doesn't matter which. I'll use this one that I'd set up over here. So I'll say that a sub 15 is equal to a sub 1 plus 14 times -5. So I got the 14 from here, the -5 from here. A sub 15 is -36, and that's equal to a sub 1 minus 70. When I add 70 to both sides, I find that a sub 1 is equal to 34.